What is PLC and how does it work? Hello, I am Tom, your virtual instructor. Stay with me until the end of this video, and we will see what is PLC, how does it work and for what it is used. So let's check it out. PLC is a computer. But it does not have monitor. Does not have keyboard and mouse as well. It does not have CD drive or hard drive. It is special computer designed for industrial environment. It is able to operate in wide range of temperature and humidity. PLC is acronym of Programmable Logic Controller and it is used to control machines and processes. It is compact design and fit to the electrical cabinet. Provides flexibility in programming and high reliability, no program crashes or mechanical failure. Before PLCs were invented, machines were controlled by electromechanical relays with complex wiring. This approach is called hard-wired control. These systems were complex and extensive. It took up entire walls, what requires a massive wiring. Relay logic is a hard-wired control system using instrumentation, switches, timers, relays, contactors, motors and actuators. Before PLCs were invented, machine and process automation was accomplished using relay logic. Automating a machine using relay logic requires a massive wiring and magnitude of devices to perform even the simplest of tasks. Today, relay logic is done in PLC, which provides flexibility in design, modification, maintaining and troubleshooting. Also, implementation of control system is simplified. Today most industrial automation rely on PLC like oil industry, car industry, food and beverage industry, chemical industry, etc. PLC is able to read statuses and measured values from sensors via inputs, such as temperature, level measurement, or even push buttons or switches. And based on user program which executes in the PLC, it is able to manipulate with outputs in order to control machines or processes. Devices which are connected to the outputs such as valves, pumps, motors, heaters, etc., are called actuators. As an example, let's analyze following scenario. There is water tank with temperature control. To maintain temperature of water, there are temperature sensor and heater. When temperature of water drops below 20 degrees Celsius, heater will start until water temperature is reached 22 degrees Celsius. Water tank can be refilled by pump. To check water level we have level sensor. Below there are outlet valves to supply nozzles for watering of plant. Task is to start outlet valves every day at 7 p.m. and let it run for 5 hours. This will cause discharge water tank. When water level drops below some level measured by level sensor, pump will start to refill water tank until reaches some level and then pump will stop. All this control is done by PLC. Brain of industrial automation equipment is industrial computer or PLC. To monitor statuses of machine or process, the eyes of the automation system are sensors. To do some action, the hands of the automation system are actuators. Central Processing Unit, CPU, is the brains of the PLC. CPU stores and runs the user program. The input-output system, often referred to I/O system, includes modules with I/O channels that connect to input devices such as switches and sensors and output devices such as valves, motors or pumps. Some PLCs comes with integrated input and output terminals. Power supply module is an optional module that can be used. Power supply module provides appropriate voltage level and current to supply PLC. In practice, power supply can be external instead using power supply module. How does PLC work? Before we continue, if you like this video, be sure to click the like button down below, subscribe, and a bell. This way you will receive notifications of new Tom's videos. After power on PLC and get into run mode, startup tasks executes. After startup, PLC has following sequence of operations. The CPU reads the statuses of input devices and records this information in its memory. Executes the user program and changes internal memory values as needed. Performs internal diagnostic and communication tasks. Sends updated status information to output devices through the I/O system. This sequence of operations is called PLC scan cycle, and is repeated continuously as long as the PLC is in run mode. Time required for the scan depends of the capability of the CPU, the size of the user program, the number of the I/Os and of amount of the communication required. Typical PLC scan is measured in milliseconds. This means that PLC response time from reading an input to reacting by changing an output is also very fast. If PLC from any reason get into stop mode, PLC scan cycle is not executing. Usually PLC supports several communication protocols what provides ability to communicate with other devices. Often is used some Ethernet-based communication protocol. Human-machine interfaces or HMIs are often connected to the PLC to allow factory personnel to monitor and operate machine or processes. HMI is permanently connected to the PLC and communication is established. All data presented at the HMI are cyclically refreshed. Sometimes hardware buttons can be changed with graphically presented button at the HMI what reduce wiring effort. Programming devices is used to load a user program to the CPU memory. Programming devices are usually desktop PC or laptop with the installed software that allows to create and modify PLC programs. The programming devices are connected to the PLC only when it is needed. Thank you for watching. Don't forget to click subscribe down below and see you in next video. Bye.